Hello everyone, and welcome to Chapter 6 of our 2D drawing learning series. In this chapter, we will be covering 4 main sections. First, we will have a basic introduction. Second part, we will look at create and edit views. The third part is about dimension, annotation, and symbols. Finally is 2D drawing for assembly. Let's get started with basic introduction of 2D drawing. Same as Solidworks, 2D drawing has sheet format, views, dimensions, balloons, and boom. For creating 2D drawing, it's a little bit different from Solidworks. There are 3 ways to enter 2D drawing environment. First is DA toolbar. You can click on this icon to create and enter 2D drawing. Second, you can also use right-click menu. And the third one is same as Solidworks, which is directly create a new 2D drawing file. Next, let's move on to the views. At first step, we will create the standard view. Unlike Solidworks, ZW3D cannot drag the view from the view palette. We can use 2 ways to create it. By the layout feature or by using the default standard together with projection to insert basic and projection views at once. For the layout function, you can choose the views you want to place, allowing you to place all the views at once. When placing view, you can also change the display mode, line display, scale, and so on. And for the standard view, it will only create one view, but we can get into the projection function after choosing the location point. After creating views, we can drag the view to change the location. Also, we can double-click the view to change the setting. Now, let's move on to the section view. There are 3 common used section views. They are fully section, aligned section, and isometric section. For the full section, there are 2 ways to create it. First, we can select points to locate the section line. Here, activate the full section function, select the base view, and select the location point. Then, click middle mouse button. Also, you can set the method. Set curve mode will only show the section profile, and the trimmed part will show the projection. Second, we can use Sketch to create full section view, which is similar with Solidworks. Here, define the sketch and select the base view. Go on, select the sketch. You can choose the exist sketch, or here we can use right-click menu. Directly create a new sketch. Okay. Next is align the section. The step is similar with full section. Here is the example. We can locate the section line with points. If the part have more than 2 holes and you want to make a section view for all the holes, we can use band section. And for the band section view, 3D name section view, and isometric section view, they all need a named section. Here I will show you how to create it. First, we need to create an open edge sketch. Draw the section line as we need. Then, click the Wireframe ribbon tab and activate the Name section function. Select the sketch and input the name. Next, get into the 2D drawing and activate the band section. It will identify the available name section. Finally, is isometric section, which also need a named section. Here, I already create a name section. Let's get to the 2D drawing. Activate the isometric section, and we can select the view direction. OK. Also, here we don't want the hidden light, and we can double-click the view and close this option. Also, we have broken section view, which can create part of the section view. For example, here we just want to create a section for this hole. We can activate the broken section function and choose this view. Same as Solidworks. We can use polyline to create the boundary. And for the depth, we can use point location instead of calculating the distance, just like this. It's more clearly and efficient. Next, let's move on to the detail view and the crop view. It's very simple. We can just activate the function, choose the base view, and select the boundary type. Click the middle mouse button to go on, and OK. Also, the crop view has the same workflow. Next, it's dimension, annotation, and symbols. First, let's start with dimension. We can use this dimension function. It can automatically identify the type of object, which can cover most requirements. Also, if you don't want to create the diameter for the linear dimension, you can close this option. Here, I want to mention the ordinate dimension and the hole callout. The ordinate dimension is quite similar with the baseline dimension. It will show the location based on the original point. And for the hole callout, it's useful for the group of holes. We can also choose the information to show up. By the way, we can set the tolerance of the dimension. We can double-click the dimension and select the type of tolerance here. Also, we can use modify tolerance function to do that. Next is annotation and symbols. This section mainly covers Dalton feature, geometric tolerance, surface roughness, and so on. First up is Dalton feature. We can click to attach the labels and set the symbol style. Next is feature control. Here we can click the command, select the object, and place the symbol. For example, we can set a perpendicularity with Dalton A, and we can add more symbols by clicking New in the drop-down menu. Here, let's set a flatness. Also, we can hover on this plus icon and add the symbol we need. OK. The last one is the surface roughness. We can click this command, and here we can set the attach mode and the symbol type based on your need. Then we input the value and click OK. Here we have a tip for you. To manage all the style format in 0CD, we have the Style Manager function, and we can see all the styles are listed in here. You can change them based on your need. After setting the Style Manager, you can also export it as your standard style so that you can share or reuse it. Finally is 2D drawing for assembly. This part will show some common used functions for assembly, such as balloon, boom table. First, let's talk about balloon. Here I will use a explode view for example. We can create a view with explode mode. Also, we can set the view as we want. And we get into the advanced setting and select the explode view. Okay, then we can use this auto balloon function to create all the balloons. Set the type and click OK. Then let's create a boom table based on the balloon. Activate the boom function in the layout ribbon, and here we can select the attribute we want to show in the table. Here we have the system attribute and the custom attribute. And we can click OK and choose the origin and the location point. Now we have the boom table, but some columns are too long. We can change the size here. And also we can export the table as a boom template. You can reuse it in the boom function like this. Also, you can set the boom template in the configuration. At the end, I have several tips for you. Firstly is the whole table. For some case, with so many different types of holes, we can use whole table to list them all. For example, here we have the model and we will create a top view. Then, activate the whole table function. Here is the filter to select the holes we want. And the original point. Also, we can combine the hole with same size or ID. And for the numbers, we can choose to start with numbers or English letter. Then, click OK, and we can get the whole table. By the way, we can also select the attribute to show and whether disable the leading line. Second is multi-editing for dimension. Firstly, we can hold the Ctrl key to select multiple dimensions and change the tolerance at once. Second, we can also use the Format Painter to copy the tolerance to other dimensions. And that's it for our overview of 2D drawing. I hope this helps you get a better understanding of how to use diversity for your 2D drawing creating. If you have any questions or need further clarification, feel free to ask. Thanks for watching.